Have you ever heard a fact that just sounds, well, wrong? Today, we're diving into one of the absolute strangest paradoxes in our entire solar system, and it's happening right next door, on our planetary neighbor, Venus.
Really think about that question. How on earth can a single day possibly last longer than a whole year? It sounds like a riddle, but it's not. It is the bizarre, mind-bending reality on Venus, and we're going to break down exactly how it works. So, to untangle this whole thing, we've got to start with the basics. We need to make sure we're on the same page about what a day and a year actually mean when we're talking about planets. Okay, let's start with a year. Scientifically, that's called the orbital period. It's just the time it takes for a planet to make one full trip around the sun. For us on Earth, that's about 365 days. Simple enough, right?
And then you've got a day. That's the rotational period, the time it takes for a planet to spin one complete time on its own axis. That rotation is what gives us our familiar cycle of daylight and darkness, and for us, it takes about 24 hours.
All right, here's where it gets absolutely wild. Look at Earth's numbers. Totally normal, exactly what you'd expect. A 24-hour day, a 365-day year. But then, look at Venus. It takes a staggering 243 Earth days for it to spin just once. But it only takes 225 days to go all the way around the sun. A single Venusian day is longer than an entire Venusian year. Let that first number really sink in for a minute. 243 Earth days. That's the unbelievable amount of time it takes Venus to complete just one single spin.
And yet, in only 225 Earth days, that's nearly 3 weeks less time, Venus has already completed its entire orbit around the sun. Before it can even finish one full day, a whole new year has already kicked off. It's just insane.
But hold on, the strangeness does not stop there. As if a day being longer than a year wasn't weird enough, Venus has another pretty major twist.
Get this, Venus spins backwards. It's called retrograde rotation. So while Earth and almost all the other planets spin counterclockwise if you look at them from above the North Pole, Venus just goes its own way and spins clockwise.
The result of this is just surreal. If you could actually stand on the surface of Venus, you would see the sun rise in the west and set in the east. This whole backwards motion is a huge clue in figuring out why its spin is so incredibly slow.
Okay, so we have the bizarre facts on the table. Now for the really big question. What kind of cosmic forces could possibly create a planet this strange? It's the question that planetary scientists have been wrestling with for decades. What forces out there are powerful enough to slow a planet down to a crawl and maybe even flip its spin completely around?
For a long time, the leading theory was some kind of ancient cataclysm. A giant asteroid slammed into Venus way back in the day and just knocked its spin all out of whack. But more recent evidence is pointing to something more subtle, but honestly way more powerful: the planet's own atmosphere.
That's right. The leading theory today isn't some single ancient event, but an ongoing process. A process driven by Venus's own crushing, super-toxic air.
As astrophysicist Stephen Kane puts it, the atmosphere on Venus isn't just weather, it's a geological force. We tend to think of an atmosphere as this thin little veil on a planet, but on Venus, it's a dominant power that literally shapes the world itself.
So here's how it works. It's basically a giant cosmic tug of war. On one side, you have the sun's massive gravity, and it's constantly pulling on Venus, trying to slow it down into what's called a tidal lock, where one side of the planet would just permanently face the sun. But on the other side, the sun's energy also supercharges that thick Venusian atmosphere, creating these howling, unbelievably fast winds. That atmosphere is so thick that it creates a powerful friction with the surface. It's literally dragging against the planet, acting like a giant brake. It physically pushes against the planet's rotation, slowing it to the crawl we see today.
So why does all this matter? It's not just a cool piece of cosmic trivia. Understanding Venus actually forces us to think differently about our own planet's history and how we look for life somewhere else in the universe.
Earth and Venus are often called planetary twins, and for good reason. They're incredibly similar in size and mass. But they couldn't have turned out more different. One became this beautiful haven for life, and the other became a toxic furnace, with surface temperatures hot enough to melt lead. The biggest difference between them? Their atmospheres.
Venus is the ultimate case study. It is living proof that a planet's atmosphere can completely rewrite its destiny. And as we discover thousands of new Earth-sized planets orbiting other stars, the lessons from our evil twin next door are absolutely essential. They help us tell the difference between a distant living world and a toxic Venus-like wasteland.
And that leaves us with a pretty cool final thought. If a planet so similar to our own, right here in our cosmic backyard, can hold such a profound and mind-bending paradox, well, it just makes you wonder what other impossible things are waiting for us out there in the universe.